Hello everyone, we will be learning in this video about the Jacobian. Jacobian is related to the functions which are involved with some variables which are independent variables. Like whenever we use the word or the term Jacobian, it represents matrix and determinant. So first of all, we will try to understand what is its definition. If u and v are the functions of two independent variables like x and y, for example, so then if you want to write it's a Jacobian, then how we write with respect to x and y, how we write it, j is the letter which we use it to represent it. So j of uv with respect to, and the denominator which with respect to which variables we are writing, that we will write it in the denominator, and that will be equal to partial differentiation of like uv with respect to this variables which are x and y over here. So how we write that determinant is, it's a simple, since uv are the functions of x and y. So first of all, whatever are the variables with x and y, with respect to that we will be differentiate given function. Like here u is like a function of x and y, so this is first of all we will write del u upon del x, and similarly it is a function of y, so del u by del y. Similarly v is also the function of u and v, so we will simply differentiate it with respect to variables. So since x is one of the variables, so del v upon del x and del v upon del y, and we will write this in the form of determinant. So that's how we write the Jacobian. Okay, we understood the definition and we clarified the definition. Now how we apply it, or where we apply this Jacobian, it's common, one of the most common use or application is when we want to transfer the coordinates in the coordinate system, like from one form to other form. Like for example, we use the coordinates in Cartesian form, in polar form. So if the given coordinates are in one system, and if we want to transfer it in other system, so mainly we use Jacobian for that. So for example, I have given here x is equal to r cos theta, and y is also given as a function of r and theta. Same like here, x is a function of r and theta, y is a function of r and theta as are the variables. So what we do it to write the Jacobian, simply given function we will be differentiating with respect to the variables. Since r theta are variables, we differentiated x with respect to r and with respect to theta. Same goes with y also. Y is also function of r and theta, so we differentiated with respect to r and with respect to theta, and we found the Jacobian determinant for it. So this is one of the application of Jacobian where we use it. So before we actually start with the questions, we will go through the properties of Jacobian, so it will be easy and we can apply them in the questions. So properties of Jacobian, first property is, if u and v are two functions of x and y, then what we can do is, how we can find the Jacobian is del of uv upon del of xy, and j dash, that's nothing but it's just opposite, means here in the first case u and v are functions of variable x and y. Now how we find j dash is, now x and y, in this case we make it as a function of u and v, so it's the exact opposite case of this one. So now that's why we call it as a j dash here. So whenever we take the product of this j and j dash, then it will always return 1. So this is one of the important property. Like here we just change the variables. First of all, given was uv are the function, uv are two functions which are in terms of x and y. So here that's how we find j, and how we find j dash is we changed it. Now the x y we make it in the form of u and v variables. So, and whenever we take their product, it always return to 1. Now, let us move on to the second property. If u and v are functions of r and s, and r and s are again the functions of x and y, it is pretty similar like how we do it in partial differentiation also. We apply the chain rule even in the regular differentiation also. So, here the uv is function of r and s, and rs is function of x and y. So, we will apply here chain rule, and how we will do it. So, we will take the differentiation of uv with respect to x y. If you want to find, then we will simply apply it by chain rule. We will be doing differentiation of uv with respect to rx, and we will take differentiation of rs with respect to xy, and same way we will write their Jacobian as well. Now, next is implicit function. So, if you have given function in the form of the given function uvw, they are involving 3 variables x1, x, y and z, and if they are not independent, means when we learned about the implicit function, we have learned that whenever we say the implicit, means there is some relation given in between the variables, like for example x square plus y square plus 2z or something like that. So, these variables are related to each other. So, that is here they are saying whenever these variables are not independent, means there is some relation has been there given in between. So, whenever this kind of situation is there, we call it as an implicit function. So, whenever this given function is having the variables which are not independent, in that case whenever we will be finding their Jacobian, then it will always give you 0. So, in short, what we can say, the Jacobian of implicit function is always equal to 0. So, these are the important properties of Jacobian. Let us discuss in more details in next video.